did I put that? Oh, there it is. And I'll get it up here. So number 2 was a big problem. Yeah, so yeah, so there were some a few minor complaints about these problems, that they were a little bit more picky than I had led you to believe. So let's take a look and see, and bear in mind that I pushed the date back so that you can do this later today if you want, pick up the pieces, and we'll correct what we need to. So let's just go through one at a time, make sure that we're okay with these. So this number 1, I think this one was pretty, yeah, this one was pretty good. I guess my problem was that in my homework preview, I hadn't scanned down far enough to see number 2. That may have been the problem. But were there any issues with number 1? We kind of started it last time, didn't we? We had some ideas on how to deal with it. Okay, so we're in good shape with that one. Let's take a look at number 2 then. That was the one that caused some grief and suffering. And it's because you actually have the function here. And the function, that gives you the ability to actually compute. You don't have to estimate how tall these rectangles are. You can actually compute how tall they are with the function. So let's actually do part, which one do we want to do? It says find right endpoints. Okay, so we'll do the right endpoint one. And my function is 3 over x. Just so that you know, if yours is different, then you just have to adjust. So 3 over x, this is the correct picture, by the way. I'll click that. And then let's actually do this calculation. I'll do it on the iPad. So we have, I'm going to draw, and then I will switch over to iPad land. So. Okay, so here is my picture. I'm trying to find this area. And so each of these touches on the right endpoint, which means that this one right here, the one on the right, the furthest to the right, well, it's supposed to touch right there. That will be 3 over 2. That's the only one that's the nicest of the bunch. The rest of them aren't going to be quite as nice. You have to remember that this, each of these, this is 1 1/4, which is 5/4, 1 1/2, which is 6/4, 1 3/4, which is 7/4. Those are the coordinates of the x values. And then to get the y values here, I'm just plugging these into this function here, 3 over x. So 3 over 7/4 is 12/7. And then 3 over 6/4, oh, that's actually pretty nice, isn't it? That's 3 over 3/2, that's just 2. Is that right? I hope. Let me do it, I better do it. 3 over 3/2. Yeah, that's just 2. And then 3 over 5/4, which is 12/5. Now I can compute the areas of each of these rectangles easily and have an actual precise number, which was the big problem, is that I had said, spouting off the cuff apparently, that you could just estimate, but in this case you actually have a function, so you can actually compute the actual value. So let's do that. This is going to be 12/5 times 1/4 plus 2 times 1/4. So I'm just doing this area, and then the second one is that area. And then 12/7 times 1/4, and then 3/2 times 1/4. Okay, so what is this going to be? 12 3/5. Well, this is going to be fun, I can tell, especially with this next one, 3/7, and then 3/8. Lovely. So this will be probably calculator. Time to pull out the calculator. I could probably do this in my head if it wasn't for that 3/7. Although 3/7 is like 0.42 something. How many digits do they want us to have?
4.
Oh, yeah. 4217? I don't know if that's right. Let's check. 3/7. There's a trick to know. I used to know the trick, but I don't know now.
I think it's 428. No.
Yeah, 428571.
Yes.
Yeah. And, yeah, 428571, 428571, blah, blah, blah. But anyway, let's just go ahead and do this. I'll add them up. 3/8, which is easy. 1/2, which is easy, but I'm typing it into my calculator nonetheless. And 3/5, which is easy. So I got 1.905, sorry, 1.9036 if you round. Let me type it in and see if it's right so that we can be happy. 1.9036. And is this under or overestimate? Well, here we talked about this. This we did talk about. You can see that we're leaving out a little bit of area here. So if you've got the right diagram, then you can see that we're underestimating the overall value of this area. So we're underneath the truth. Okay, whatever, we can do the rest of this on your own because those other ones are pretty simple. Come on. Why do I have to scroll so far? There. Submit. Let's see if I got that, at least that part right. Oh. Uh-oh. Oh. I see. I typed it into the wrong block. What was it? 1.9036? Okay, let me just do this. Come on. Go to the end. There we go. Try one more time. Oh, phew, got it right. Okay. So I just wanted to double check that I was doing it right, because if I can't do it right, then you might not be able to do it right either. All right, so that's number 2. Number 2B, the last part of number 2, very similar, except for you're using the left endpoint. So actually this, oh wait, why is that one checked? Yeah, this should be the other one. Oh, I don't know why that one got checked. Should be this one. Yeah, this one is the correct one. But anyway, yeah, so this is the correct diagram for 1A, or whatever it is, the first part. And then 1B, or 2B is almost the same, except for using the right endpoints, left endpoints, and so you would do whatever function value here, that's 3 times 1/4, and then this times 1/4, and that times 1/4. Hopefully you can handle that. But let's just dwell on number 2 a little bit longer because it was so painful for some of you, and we want to just have the time to grieve as needed. Yes?
Can you go over the math one more time?
For this thing here?
Yeah.
Yeah, so the first step, and this was the step that we kind of omitted last time, was to figure out how tall the rectangles were. And so to figure out how tall each of these rectangles are, you're going to need to know the function at this point here, for example. So let's just focus on this first rectangle. So this first rectangle, its height is the same as the function at 1.25, 5/4. That's right there. And so what I did was I just plugged 5/4 into this function. And I got, so this is f of 5/4 is equal to 3 over 5/4, which is the same as 12/5. So that's where I got the height. Then I did the area inside this rectangle is going to be that 12/5 times its width, 1/4. And I did that for each of the rectangles. Added them all up. That's where I got my final answer. So yeah, so you do each rectangle independently, and you can get the height. So the tedious part was that the height, you couldn't figure out the height just by guessing. That was the problem that made some of us angry.
I'm not angry anymore.
Okay, you have become calm and ameliorated, or whatever it is. Okay, very good. All right, anything else about number 2? So more 2s. We got to get it out of our system. 2. We're happy with 2. As happy as we're going to get. All right, let's take a look at the rest of this. See if there were any other issues. 2 is the big one. So yeah, here again you're given a function, and here again, and here this whole business about the number of rectangles use that. Shouldn't be too big of a deal, but, is there anything that we want to talk about with this one? Okay with that? I know, it's, yeah, once you realize that you actually have to figure out the function values using the function, like the heights of the rectangle, then these are just tedious. It's not so much, yeah. Yeah, and this is the only time I'm gonna make you do this, just so you know.
The only time?
Okay, and on the test.
There it is.
One more time, thank you. Oh, and on the quiz, I've got a quiz today.
Yay!
However, wait, where's the quiz? What did I do with the quiz?
Please tell me you threw it away.
No, I got it right here. Yeah, I've got the graph for you. It looks beautiful.
Nothing. I'm committing crimes. Let me.
You do whatever you need to over there with that thing.
Well, by proxy, because you're sitting at my desk.
Well, anyway, let's go on and talk about the speed. So if we're okay with the areas, I know after we finally figured out
Yeah, I got
what the situation is. What do you think about numbers 4 and 5, where we're dealing with speed and distance?
I thought it was highly entertaining.
Yeah?
No, I didn't.
What about this one here?
I thought that one was really easy.
Oh, it's too easy.
I thought that was
It
pointless.
gave you like half the numbers. and
Yes.
said you like,
Oh, I see. Yeah, you go through. Yeah, I know.
it was like,
It was a
like 15 times, what number is this number? And I said, oh, I don't know.
And the only math that you had to do was add them all together.
Okay. Well, yeah. So just in my defense, I had two options for this problem, and the one that didn't give you any help, it said would have taken you, at least on average, took students like 21 minutes, and the one where it gave you step by step, it took students 9 minutes. So I thought, 9 minutes, 21 minutes. If you had to figure it out all, I don't know. So I thought it might, you're learning something probably. So it's too easy. Sorry about that. I'll make sure that they're harder in the future. Just for you.
Thank you.
All right, you want to do one of these? Let's do it. Let's do a quiz. It'll be fun. It won't be difficult. So this one is like number 2. Sorry. Except for if you want me to, I will give you the function values. So if it bothers you that you have to compute the function values, I will give them to you. Give me a sec. I'll put them up on the screen. Unless you want to start computing right now. Here, send one over there towards him. There you go.
Computer? I hardly know. This one's fun.
Yeah, it's not bad. It's not bad. But just for those of you, just to do penance for giving you number 2, I can actually put the function values here, right in points. Just a sec. So you can do them yourself as well. Oh, I see. I didn't put it up on the screen yet. Okay. Oh no. Oh good. Yeah, no, go get it. Go get it. Yeah, you need your tools. I'm glad it's not some emergency. I was worried that you were going to say that someone's being arrested and I had to vacate the building or something.
Has that happened?
That has never happened, thankfully. In all my 26 years, I just made something up. Come on. You know me.
I mean, it was a little extreme.
And it was oddly specific too.
Yeah.
You didn't say, oh, there's a convict or something. You said arrested.
Yeah. I have been served, what was it? I was subpoenaed. I was subpoenaed once. That was exciting.
For what?
I can't say, but the college attorney said, just sit on that for a while, and then it'll go away. And I was like, okay. It was not something, I was supposed to testify about something that I was privy to. It was not, I wasn't, but anyway. Yeah, something that it was a very strange situation.
Did you not multiply by a really important number? Okay, let me help you out.
I'm having trouble now for some reason. I feel like it shouldn't be this.
I'm just going with
Right?
it.
That's not right, is it? That can't be right.
Did you happen to get a number that ends in .25? Okay. Hey, there are infinite numbers that should end in .25.
Oh, I see. I can't do simple arithmetic. I can do the, here we go. Okay, yeah, you probably were ignoring what I'm bringing up here. Those are the function values.
Oh.
Finally.
I kind of ignored that.
Yeah, that's fine, that's fine. It's probably best. I said I was gonna put the function values up there if you were
Did myself.
bitter about having to compute them yourself. Okay.
Did I have a piece?
Next time, I'll make sure I bring one for you too.
I don't know how to solve them.
No, I'll get you one. I'll bring a simple one.
You should, you
I mean,
should.
2 by 2. Can you give me a 2 by 2?
No.
Yeah, I can bring it.
You should give them.
I know, the simplest one I have.
If it's just gonna be a cube, I would be angry.
I know, which one he's gonna bring you.
No, I can bring them the second easiest,
Give them, like,
Yeah.
yeah.
or the third easiest.
I'm worried.
That's funny.
Tuesday, since Monday is optional, I don't know if you'll show.
Oh, I won't be here.
I'm sure I will.
Actually, I might come just to give you these.
Oh, to show me that you solved them, that's fine.
What do you mean? I thought we were talking about just cube.
Yeah, it's done, solved.
Well, you went very quickly from Rubik's Cube to, oh yeah, I got the answer right. And I didn't see what the conversational jump was.
Yeah, I have it in my head, I do know.
Nice. So what kind of stats effect does the bronze give you?
What? The brontosaurus?
Yeah, what, did you get like +10 health or something?
Oh, are you guys done? You're done. Excellent.
Sorry, our
Yeah.
conversation is very loud.
Okay. Wow. Brontosaurus?
Mm-hmm.
Nice, good job.
Yeah, my friend was so.
All right, you're happy with it? Yep. Good enough.
So it gives me
Excellent. Thank you very much.
+10 to it.
That's Nina's
Oh, wait.
personality, it's just joy.
No, I don't want to rush you, Raina.
I'm not just that.
You were.
Sadness.
Can I make a picture for you?
I thought about it, but then I
And I
changed
keep
my.
rushing you along.
Yeah, I was gonna draw you a flower.
Oh.
That was the
There's a
time
lot of
to
weird
get all my
shapes
colors
going
on.
on with stranger being.
Oh, wow.
I was just trying to sit there and think about it.
Okay, so there, 12.25. You did it. Good job. 100%, A+ everyone.
Yay!
Okay, so we need to move on though. So let me see if I can find what we're doing today. That's this here, not that.
What are you, why are you? Yeah, why are you beautifying your classroom?
Oh, I'm not.
Someone is.
Yeah, someone is. Well, yeah, I made a presentation yesterday to my school. this is one of the rooms that is being beautified. I ask you, what could be more beautiful than these purplish walls, resource management,
I think it looks fine.
and the best part is those
The ironing boards.
the ironing boards. I know. So anyway, when I heard that they were gonna beautify this room, I had to like step up and say, I volunteer for that committee because I just wanted to protect it, you know, from harm. Because I've seen things go awry.
I will help you because their
So-
definition of beautification is probably stark white walls.
No, we're not doing stark white, so that's good. We aren't gonna go with purple though. I think that they're looking at some sort of a pale blue. They're gonna, I know, it's whatever. Just so you know, these are all gonna go away. This one's gonna be moved over to here. Those are staying, so that was one of the things I wanted to protect because these are important
For the calculators.
for the W4, which, when we were in here discussing this on Monday, I was like, this is an important cabinet for me. There it is. So, oh, and I'm gonna get another light switch here for that light, so that that middle one is on its own switch.
The one that you unscrew?
Yeah, I'm so excited about that. So, and then they're gonna put some sort of like wall art, like words, like, okay, I know you're dying to know now. Okay, here we are.
I don't know, this just sounds kind of,
I just like
You know, that kind of deal? Somewhere back there. You don't have to look at it.
but are they gonna get rid of the,
Yeah.
Is it gonna be in that font?
This font?
Yeah.
I hope not.
Okay, oh, okay. That's
I'm
what
on the
makes it
committee.
bad.
I can help. So,
That's what you want it to be, not that anything but Joker.
I'm not sure. I'd have to see what the options are, because they work with a particular company,
do
so.
we have a petition for this?
No. It's bad enough, I'm dealing with the science people, and we're trying to figure out what kind of a quote, so it may just be like the flame back there, I don't know. So, it's, yeah, the MVNU flame? Anyway, that may be what's back there, I don't know, but,
You could try to just take the one from the post office that says wash your hands and say your prayers.
it says that on the wall in the post office?
The old post office,
Oh, the old post office, okay,
because Jesus and germs are everywhere.
that's great. Okay, well, anyway, let's do the definite integral so that we can move on. Riemann sums. So just so that I had said the word, the phrase, the Riemann sums, what we've been doing up until now are called Riemann sums. Back when I was a student, this is like 35 years ago, doing calculus, I had to do so many Riemann sums. And so when we got to the fundamental theorem of calculus, and I found that the fundamental theorem of calculus saved me from doing Riemann sums, that became my favorite theorem, and it is to this day my favorite theorem of all of mathematics is the fundamental theorem of calculus. We'll talk more about that on Tuesday, but this thing, what we just did here, is called a Riemann sum, named after a mathematician named Riemann, and he did some sums. Anyway, the definite integral, and we're going to come full circle here, but right now what we're going to do is we're going to introduce some notation for what's called the definite integral. The definite integral is literally the area under the curve. So when we talk about the area, oh, here's the definition of a Riemann sum. So now you can see, don't write any of this down. Now you can see why I found this subject to be so horrific and was so happy when I got to the fundamental theorem of calculus and was saved from having to do this. But anyway, so we won't dwell on this much, but basically all this says is that if you have a bunch of rectangles and you shrink, we talked about this already, we shrink the rectangle size down, then the smaller we make the size of the rectangles, the closer we're going to get to the actual area. So all of these rectangle things, those are just Riemann sums. Here's just an example. Here's a picture. And let's just get on to this. So the definition, okay, let's not do that. Why did I even include that?
What was that?
We don't want to know.
I want to know.
Okay,
Very
well,
curious.
I'll just say briefly that back in the olden days, we used to make a big deal about the fact that you could actually figure out the area under a curve using a limit. This is akin to the limit definition of the derivative. And essentially what I'm doing here is I'm adding up the function values for this function, and then doing the limit as the number of little rectangles goes to infinity. So the rectangles will get smaller. So if you do this limit, you actually get the precise value of that function.
Well, how does that work? How do you compare?
We're moving on.
Oh.
Okay, so here's the deal. Definite integral is a region. So here's what we want to do today. It's pretty straightforward, pretty basic, and that is to understand that this notation means area. For now. In the future, we'll use it as a stand-in for distance if we're talking about velocity, just like when we had the runner or the space shuttle in those problems on your homework, you had to deal with distance was area. But here it's just going to be area. And if you have a function that's continuous and non-negative, then we're just going to say that the area between that function and the x-axis is going to be this notation here. So just as an example, let me just put down a quickie here. Let's say that I ask you this. What is the integral from 0 to 10 of the function 5? Okay, so I know some of you are familiar with this notation already, and you're like, I can do this using calculus. I don't want to use calculus. I just want to show you geometrically what that means. This is the area under the function f of x is equal to 5. Oh, f of x equals 5. I can draw that. That's easy. Here we are. Let's do this. Here's f of x equals 5. There's 5 right there. I don't know why I had to put it on both ends. Here's 10. And I want to find this area. I'm pretty sure that each one of you could find that area. What is that area?
50.
Oh, it's, okay, 50. That works. But anyway, this is so. Yeah, now, doesn't 50 Cent have, doesn't he have a son?
What is it, like, quarter?
Well, that's what I was wondering. I'm pretty sure, I heard this a while back, that he had a kid, and he named the kid something really ridiculous. Like even worse than 50 Cent.
I'll look it up.
Oh, yes. This is a sanctioned use of the phone during class. Good. Let's do it. Let me know what 50 Cent's, how do you spell 50? Is it F-I-T-Y?
I think it's F-I-D-D-Y.
Yeah.
Ooh. Oh, so I've been pronouncing it wrong all my life. I thought it was F-I-T-T-Y, 50, but it's Fiddy with a D.
Perhaps. I'm not sure myself.
And then-
That's just how I see it in my head.
And then just like that, Cent. Or is it like the French? You don't pronounce the last letter. Okay, let's move on. Here, while she's looking it up.
Okay, I got it.
It
Mm.
is F-I-D-D-Y.
Is it? Oh, what's his son saying?
One of them is Marquise and the other one is Sire.
Oh,
So those aren't that weird.
no, they aren't.
And
Maybe it was just a joke I heard once.
pretty
About.
normal.
Probably, yeah, they are pretty normal.
I was expecting like 5 cents.
Yeah, exactly. Which would be really demeaning because, like, oh, this kid is worth less than me. I'm worth a $50, and this guy's only a quarter. Okay, so here's we'll come back to this example. Let's see. So yeah, here's a few things, definitions, and some special integrals. Is first of all, if you do an integral, a definite integral of a function between a and a, essentially what you're doing is you've got that function and you're asking for the area of this little, my Apple Pencil, something's awry here. There's a there, and that's all we want is just that area of that little line, and that area is 0. So imagine you're shrinking down a rectangle until it's so thin, paper thin, it doesn't have any area. And then another thing is that if you reverse the direction of your integral, so this is just sort of notational, and it'll it'll turn out to be correct when we do all the mathematics of this with the fundamental theorem. But here's the way you want to think of this, maybe, is that if I have this thing here, and I'm finding this area, if I'm going this way from A to B, then the area will be positive, a positive number. But notice that if I switch it up and I start at B and go back to A, so the way you read this is the bottom number is the one that's supposed to be on the left, the top number is the one that's supposed to be on the right, and so if I switch it up so that the bigger number is on the bottom, then you're going the wrong direction and you end up with a negative area. Yeah.
So, a couple slides back, you
Mhm.
said that the function had to be non-negative.
Yeah, yeah.
So that means that,
Well, at least for now,
for now,
Yeah, go ahead.
so it's just, so most of the functions that we're gonna be able to
Yeah, we'll
solve
deal with
for
those, don't worry. We'll get them.
this year?
Yeah,
Awesome.
maybe even on this set of slides, but for now, yeah, we're just trying to, I'm trying to make it simple as possible for now, and then we'll extend. See, that's what we're extending to things like, so like this one, we're doing the integral from 0 to 10. If I did it the other way around, if I started at 10 and went back to 0, imagine going backwards. Then the length here is negative 10 times 5, and that would give me negative 50. So we're taking this sort of basic building block and we're extending it to other cases where things are, like here, we're starting out with A on the left, B on the right, and then here's what happens if you switch it up. So we'll get to the negative functions, not to worry. So yeah, we'll come back to that. So yeah, so here's this situation, all right. Let's see. Next thing that we should know is that if you have a function like this, you can split it up however you want. And this is useful if you have an area that you want to compute that happens to be a piecewise function like this. Here's A, here's B. Let's say that I want to find this area. Then it's oftentimes going to be convenient to break this up, maybe not often, but sometimes, break it up like this so that to get the whole area, you can say, hey, I could do the area of this plus the area of that. Makes sense, doesn't it? We've been doing this with rectangles and trapezoids and triangles and circles. So that's all this is. Just break it up if you need to. Mainly, we're just trying to deal with some notation here. I think the homework here is going to be pretty easy once you understand what the notation is. Okay, so we've got that. A few other things is that if you have a constant times a function, you can do the area here. I'll do a quick example of this. Let's do this particular function here. From 0 to 6. Okay, see if you can come up with that definite integral just using geometry. I'll help you out by drawing it.
Oh, it's gonna be a triangle.
0. And then we're going to do this. Oh, 6, 6, 6. Okay, so let's do the one on the left first. The one on the left is pretty easy, and I know, Sam, that you can do the area of this triangle, can't you? Sure you can. How tall is this triangle?
6.
It is 6 tall, and how wide is it?
6.
And you know the area formula for a triangle. So put it all together. That's right. So 6 times 6 divided by 2?
18.
18, that's beautiful. So that's going to be 18. Nice. Now over here, after I messed up writing the number down here, I've got this function 10 times x that goes up. I can't even draw it because it goes off the screen. And so how do I deal with this? I know, you can deal with it. You're smart. But let's say that you didn't want to have to draw it and you've already done this over here on the left, what you could do is use this first property and write this like this. This is going to be 10 times the integral from 0 to 6 x dx. Essentially, this is just saying that this new triangle, this tall one, is 10 times the size of the small one over here. So the final answer is just going to be 10 times 18, which is 180. So that's one thing you can do to make life easier for yourself. Another thing you could do is you can use this property here that says that if you have two functions, a to b, of x plus 5. Oh, sorry. I should have put something other than a and b. Hold on a sec. How about this? 0 to 6. And if you've already done the work, I know this one's easy. You could draw this and do it geometrically. But if you've already done the work for the x here, you can separate that out. That's all this says, is that you can take this and you can write it like this. The integral from 0 to 6 of x dx plus the integral from 0 to 6 of 5 dx. So the x dx, that's the easy one. We've already done that. It's 18. The 5 is similar to the one that we did that's just a rectangle, 5 units by 6 units, and we can all do that. 5 times 6 is 30. And the total here is going to be 48. By the way, this gets us to the question that of the negatives. Let's see, is it on the next slide? Okay, it's not on this slide yet. See, I want it to be here somewhere. Okay, I don't have it here for whatever reason. Okay, I'll put it on this slide. I'm going to just erase all this. So the question of a negative function. So this gets us to that. So let's take a negative function. Let's do this. The integral from a to b. Oh, why do I keep putting a and b on there? I guess because I'm just copying blindly. How about 0 to 6 of, how about negative x? Well, let's take a look at this property that we just went over, which I'm presenting all these properties without proof. You're just going to have to trust me that they work, I guess. But this property says that if I have two functions and I either add them or subtract them, I can either add or subtract the definite integrals. And so you might say, hey, that's only one function. Well, it looks like one function, but I can always stick a 0 in here, can't I? That's the same. In fact, I gotta admit, when I'm coding, sometimes I'm a little scared of starting off, or like if I use a calculator, I'm scared of starting off something with a negative, and so I'll put a 0 there to just be 0 minus. It's the same thing, right? 0 minus 5 is the same as negative 5. So anyway, now we've got this. I can separate this into two separate definite integrals. The integral from 0 to 6 of 0 minus the integral from 0 to 6 of x. Now let's see if we can do these. We already know this one. This one's 18. What about the integral from 0 to 6 of 0? Oh, I don't need this thing, because Matt knows the answer, don't you? You know the definite integral there?
That would be 0.
It would be 0, yeah, because you're dealing with a rectangle that has 0 height and 6 length, but the 0 height, that's what's going to kill it, 0. And there's negative 18. So here, what happens is, if you have a function that's below the x-axis, you can do this little trick, although you don't have to do it. In the future, we won't need to do this with the fundamental theorem, but you do end up with a negative area.
So
So
it's, sorry,
Yeah, yeah. Oh, yeah. Yeah?
Can you just call it a negative 1?
Yeah, you could have done that as well. Yeah, I realized that as I was writing this down. It's like, wait a minute. This would have been quicker and easier, wouldn't it? So, anyway, yeah?
That's specifically for things that go under the x-axis,
Mm-hmm.
which means that things that go
Both up and
negative
down.
x over there,
Oh, over there.
for you.
Yeah. No, it's over there for me
It's-
too.
Oh, wow, okay, that's fine. You can still solve the area without having.
Yeah, yeah. So how about this one? Let's just to deal with Jarrett's issue. How about from negative 10 to 3? Let's go from negative 10 to 3 just to make it more interesting. Of let's see, how about, gotta make sure that it works out nicely. How about 5 minus x? And we'll do this now. Like I said, once we get to the fundamental theorem of calculus, we don't have to think about areas in terms of geometry anymore. We'll just use calculus. But for now, we're thinking in terms of areas. It's a bit of a pain. Let me sketch this thing so that you know what it looks like. Whoops, I should just get rid of that line there. Try again. Here we are. So here's -10. Here's 3. This is a line that looks something like this. I'm interested in this trapezoidal area right here. And so you'll notice that even though you're dealing with a -10 here, that's what you were worried about, is the negative here?
Yes, because it says non-negative.
Oh, non-negative functions, not the x's can be negative.
Okay.
There's the function, yeah, this is fine. Yeah, so we're dealing with this area. And actually because of these two theorems or properties, we don't have to worry about the negative functions either. So even though we've defined this thing as only positive functions, now we can deal with negative functions. But here, this is just, you can deal with this area. This is 13 pi, whatever this is, that's 2, and this is 15. So 1/2 times 15 plus 2, all times 13. Whatever, yeah, just get the area. Okay, so let's see, what do I got here? Let me make sure, oh, what I have is, I thought I deleted all the ink. Just a minute. I thought I deleted this. I'm glad I did a preview, because it's always embarrassing to see the ink that I put on the screen last semester. There we go. Almost there. Delete. Delete. One more delete. Delete. Okay. This will at least get us started. So here's the sort of thing that you're going to be asked to do. And once again, this is all just sort of in preparation for doing the calculus. Look at this, people are dropping like flies. Well, I know, it's kind of tedious. But this is essentially all you did for homework for today, is you were asked to compute areas. So that's all this is doing. It's saying, what is this area? And yeah.
But these are just multiplication. We could do these.
Oh, okay.
We could do these without the integral.
Yeah.
So
Yeah.
I take it we're going to get to stuff that's actually.
Yeah, we're going to get to stuff. That'll be the calculus part. But for now, it's still geometry, boring, I know. So, but I just want to make sure that we can do this. And actually, I want to do, hold on a minute, just to throw a little, make it a little bit more interesting. Let me change one of these. Let's change this one from -4. No. I want to go from 4. +4. Yeah, change that one. Okay, so in each case, I just wanted, essentially, all the lesson is doing today is trying to get you familiar with the idea of using a definite integral corresponds with an area. I know, boring. The fundamental theorem of calculus is coming though. It's Tuesday, so that's going to be an exciting day. Okay, so there's that. Let's see, I'll pick a few volunteers. Random. I already bugged you. Colton's not here. I'll get him when he comes in. Raina's back. Raina, what's the area between 1 and 4?
Between 1 and 4?
Yeah, so here's 1 and here's 4. Oh, this is 4. This is 5. So what's this area here?
Could you change your color like red?
Yeah,
So
thank you.
honesty.
Did you take a little bit of inspiration from your jacket today?
Oh, yeah. Well, that's
Oh, is it
because
your Viking jacket?
yeah, that's because I'm leaving immediately after my second class because our flight leaves at 2:10, so we have to get down to the airport by 11:30. Don't you always allow like 3 hours?
About to.
No,
Only
we
when-
do like 3.
3.5 hours at the airport?
Well, yeah,
Really?
yeah, my mom gets anxiety.
Okay. Well, that's me today. Usually I give myself an hour, 45 minutes. That's fine. You show up, you get in, you're good. Okay, but anyway, getting back here.
15,
Let's do this. Oh, you got it?
yeah.
15, nice. So that's equal to 15. If anyone disagrees with Raina, let me know. She's right.
Amazing.
Okay, next one. Jared, what about from 4 to 6? 4 to 6. I'll put the 6 up here.
4 to 6.
A little harder.
I'm just gonna go on a limb and say 8.
That's not quite right. So you're doing some geometry here, aren't you? Here, let me help you out. What if I do this? Does that help? There's 2. Hey,
So it's 6.
it is 6. Very good. So once again, you're just doing the area. Yeah, I know. This is sort of baby stuff like we did a couple days ago. Boring, but still needed. Oh, look, you're back. You had gotten called on, but where you get to do this next one. So you want to do the area from 4 to 0 of this thing. So I'll highlight it for you. So we're starting at 4 and going back to 0. And it's this area right here. There we go. If you ignore that line in the middle of it. So this whole area, can you get the whole area there? Nice, 18.5. And that's not right. Okay, so why is that not right? So no, Gavin? It should be negative, yeah. Because I started at 4 and I worked my way backwards, you get a negative area. I know. This is such a common mistake on the next test. Like when I put this on last fall, I put one like this. Half the students got it wrong. They put the positive instead of the negative. So it's great that you got it wrong now. You're not going to get it wrong on the test for sure. I don't know about the rest of you, but at least Colton has been inoculated against doing this. Okay, next one, from -4 to 7. Whoa! Okay, just a minute. I have to erase some stuff. There's too much on here. So let's just get rid of everything and start fresh. We're going from -4, that's over here, all the way to 7, which is right there. Now here's the trick with this one. Since we're dealing with multiple shapes, multiple areas, this definite integral you can break up into several chunks. So what I would suggest you do is write, or you don't have to write this, you can just do it in your head, but we have this chunk plus this chunk.
Why'd you do -2?
Yeah.
I'll explain. Dx, I need the dx there. And then, I don't know, the rest of it is pretty easy. So 0 to 7, how's that? Okay, so why did I break up the first part? And the reason I broke up the first part is because this is down below the x-axis, and then the other one is up above the x-axis. Just to help distinguish between those two, because there was the question, what happens with negative functions? So hopefully you remember, but go ahead and see if you can add up all of that area, and don't forget that we have this is negative area, this is positive area, and we'll see where we are. Yes, you're right. Well, with this one, it's not pointless, it's just in this case.
This particular case.
Yeah, it's not always going to do that. All right, if you didn't hear what they were saying, Matt's going to help us out with this first part, the green and the yellow. What's the area of the green?
Oh, that's going to be 2.
It's, you say it's -2, you mean?
Oh, -2, yeah.
Yeah, -2. Let me put that down.
Oh, yeah.
So this is -2 down here. And then what about the yellow there?
Oh, it's going to be 2.
It's going to be 2, yes.
Sorry, I was...
No, it's okay. So you have -2 plus +2, and yes, they cancel. It's 0. And so, but like I said, it doesn't always work out this way, so just be aware. Okay, let's do the rest of this. Hopefully you got the rest of it after all the joy of the first part. But Claire, did you get the rest of this stuff done? 25.5. Now, just as a hint, you could have done this sort of thing and said, hey, this is 18.5 because whoever it was helped us out with that. And then you could break this. That's just 1, obviously. And then, oh, that's right, we did this, 6 here.
Yeah, I just did the integrals that we already did. I did
And just add 'em up with that
16,
1.
And then I added the 1 and the 7.
Perfect. Yeah, that's exactly what you should do, is just add them up. Good. Okay, so this is so babyish, isn't it? So we need to make it a little bit harder, so let's try this.
Okay, but it's a circle, so we'll have an area to work with.
That's right, so this is going to be a circle. What you're going to find is that all of the problems you have for your homework are going to be like this with circles, except for there will be one where you have a parabola. And I'll explain what this, we're going back to the parabola momentarily, so let's just take a look at this first. We have 4 minutes, so we got to do this one quick.
No, yes, let me square the triangle. Don't let it just be a square.
All right, let's do it. We can do this. I'm going to break this into 2 pieces, as you probably thought I was going to do. Raina, what about this triangle on the left? Do you know the area of that triangle?
4.5.
Ooh, nice, 4.5. And now we need the area of that quarter circle. Jarrett, do you know the area of the quarter circle over there?
Hold on, I forgot. It's 2.25 pi.
Oh, okay, so sure.
Okay.
2.25 pi, that works. And so the total area is 4.5 plus 2.25 pi, whatever that is, that's fine. 9 point, whatever it is, yeah. So we're good with this. So that's good enough. Let me just skip the next one. Shapes. You still have circles and stuff. It's fine. Okay, so a couple of notes on this, and then we'll talk about the parabola and we'll be done. Is when you have something like this, these are all lines. So lines you can do. Lines.
Lines are easy.
Yeah, so you can, even this one, absolute value is just this. That line and that line. So that's what this is dealing with, from -3 to 5. So that's not going to be a problem. So the big question is, well, what do I do with something like this? Let's say I want to do 9 minus x squared, evaluated from -3 to +3. Let me draw this for you so that you can see what it looks like. It looks like kind of like a side view of a gumdrop, or those delicious Dots candies that you get at Halloween.
Those things are nasty.
Oh, they're my favorites. So next time you get a handful of them, just bring them to me. Anyway, there it is. So there it is, this side view of the Dots candies. And we want to know that area. Well, at this point, not until Tuesday. On Tuesday, you'll have the tools to do this, but what you're going to find on your homework is that your homework will say something like this. They will tell you this, that if we know this, so they'll give you this little hint, that this is true. You're just going to have to take this on faith. If you know that to be the case, then can you do this one? And what I'm here to tell you is that you can, and the way you do it is you break this into 2 integrals, 9 dx minus the integral from -3 to 3 of 18 dx. So you do the 9 first, and then you do the 8, oh, not 18. Sorry, I cut right to the end. Here, sorry about that. X squared. So we can do the 9 because this is just a straight line and it's a rectangle, 9 by 6 rectangle. You can picture this. And so this thing is gonna have an area of 54, and then you subtract off this area, which we're given, and you're gonna have 54 minus 18, whatever that is. So that will be 54 minus 18, which is whatever it is. What's that, 36? Is that right? No? No?
Yeah, that's a great question.
Why is this 18?
Yes.
Because that's just given to us and you're doing it on faith.
Oh,
You're trusting that it is true. So when you look at the homework here, I'll just show you so you can see on the homework you have some problems that are like this. So here, for example, it says you're going to just take on faith that this is true. On Tuesday, we'll find out exactly why it's true, and some of you know why it's true, and that's fine. But that we're going to take on faith, and you're going to use that to find this area over here.
That's why it's 18.
why?
So-
Please explain to me why it's
I
18.
can't tell you why it's 18.
I can't do math
So-
on faith.
Because wouldn't that just be
No,
one third
well, I know how to get there.
Because at that point, I could just substitute any of my numbers for that, and it would be, it would
Yeah.
be equally
Well,
true.
Tuesday's coming.
I am, Dr. Noonan, I am sorry, I'm so frustrated with module.
Oh, Monday, we're not having class, but you can come. And I will come wander through
Can you bring some, like, I don't know, can you bring some of your tea, please?
on Monday.
Yeah. Maybe, yes,
Why?
no, I don't know.
That reminds me, I have tea on my bicycle, I'll have to go get it. But,
Do you know your notes?
oh, wait, should open up.
Yeah, can
I still have another
Hey,
class.
Claire,
Oh, let
see
me
what you
let me
did?
shut down the,
Please.
let me stop the recording so that people can't
Frustrated.
listen.